All right. So for debugging today, what you guys have done the most in your projects is basically print things out when you guys have questions as to what's going on. And that gives you some kind of error or some kind of feedback of what's going on in the project. If you guys get errors, the best way for you guys to work with that today is try and accept statements, right? So we try to do something. If it doesn't work, we recover from that on an accept statement and end up printing something out that makes sense to you. We raise some kind of exception, right? Um, you can raise your own statements if you choose to do so. So, for example, if you guys tried to convert a string over to an integer, right? And the string that you're trying to convert is not an integer, you're going to get a very specific error message, right? You guys can do a try and accept on value error, and it would actually raise for that specific value error. Sometimes in your own code, you may want to raise your own errors based on what you're going through there. So if they're doing something in your code, it's trying to execute something in there and it's not going to work, it doesn't really map to what a standard Python library is, then you can go ahead and use this raise exception function. And this raise exception will go ahead and raise this error message just like it would for a value error or any of the other ones that you guys have seen along the way. All right. So for example, if we had something like this where we had a function, a box print, it had a length and all of that, it would go through there. And then we would have a try and accept. And this accept, you'll notice, has accept exception as ERR. And then we print an exception has happened, and then we string What this means is if there's some error that pops up here, then we want to raise this in a way that we print it out to the user, the program does not crash. Does that make sense? Normally, you guys would get this in red text. Instead, we want to be able to print that out in a nice, clean form for that to go out. Okay. So, for example, here, if we actually execute that code the way it was written, it would execute this along the way until it reaches this section and says the width must be greater than 2 or the symbol must be a single character string. If we go back and look at the code, we can see those raised exceptions here. So if the length of the symbol does not equal 1, then we can go ahead and say it must be single if it's greater than 2 or the height is greater than 2. Right? So it gives us a way to create our own debugging errors. Another way to do that is pulling back the trace back, and we can go through there. That's not really something you guys need to do in your final project. If you guys were doing other things, you could do that. With assertions, this is a sanity check that makes sure your code isn't doing something obviously wrong. And you would get back assertion errors. Again, this isn't something that we necessarily push in the final project, but you could certainly do that. So what this would do is try to assert some kind of condition. And then if it does, then you can display what happens when it reaches false, right? So if it's true, it works its way through. It's kind of like a try and accept. Only when your assertion fails, the program should crash, right? So you would only do this at the point the program actually crashes. Other debugging stuff that would be of information, you can look through assertions. Again, we're not doing that. This is the big piece you guys will need for your final project, okay? And that's the logging. So with logging, before you guys were just putting print statements in to print some variable out. In this case, we want to use logging statements. And so this allows us to have an external log file that would have information as to how your program's executing, and you determine what information's in that log file. Everybody's played a game or done some kind of installation on a Windows app. You get a log file, you can go back and see what happened, where it crashed, or support says, send me the log file. You guys are creating the log file for your program. All right. If you guys have been doing well on documentation and documenting your functions and what's going on in this piece of the code, etc., you already have comments inside those places. All you have to do now is copy that comment into a logging statement so that when it reads through the log file, we can actually see what's going on at that point in time. Okay, that's what I was saying in the beginning. If you guys over comment, make sure you document everything really well. You now have the easiest part of your final because you're really just copying those statements in there, maybe tweaking them to provide the variables you want, but you already have the baseline for all those comments. You don't have to generate a bunch of stuff. If you didn't do that, now you get to, right? So logging, there's two ways to do logging. You can either log to the screen or you can log to a file. In the final project, I want you to log to a file. Okay. And I'm going to show you the code on how to do that. So this first section here where it says using the logging module, you will import logging at the top, and then you will set up this standard basic config here. We do not want to use this logging module code here. All right. If you scroll down, you will see a section that says logging to a file. This is the section of the code that I want you to actually use. Okay. It's as simple as copying this, hit Control C, you launch up idle. Maybe as it goes through here. There we go. File, new file. And then you guys would have some code. You simply copy and paste this into the file. That's it. All right. Now, when you copy and paste this, sometimes it will run off the screen and it won't be aligned correctly. Make sure you backspace so that it goes off the screen like that. All right. From there, what you can do is press enter so that it's formatted like this inside your file. So all you have to do is take this and copy and paste it, and you're good to go. When you copy and paste off the website, you have to fix that alignment. Notice that this is not aligning correctly, right? This string should be all in green. It's not because there's a space over here. So if we have backspace, now if we scroll over, you'll notice it's all in green like it's supposed to be. Best way to check is to line this all up so that you can see it like this. Does anybody have any questions on that? This is something that people fail immediately on the first time. So copy and paste. Don't copy and paste any of the other chunks of code inside the Word doc or the chapter. Scroll down to the section that says logging to a file, copy and paste this chunk in. That's like 10 points of the final exam. Okay. Like just copy and paste 10 points. All right. Once you have this in, then we actually have to use the logging file correctly. So when we use logging, we'll scroll back up here. There's various logging levels that would pertain to certain information. The lowest level, yes, it's the first one in this chart, but it is the lowest level, is the debug level. All right. That one is used for all the small details, any care messages, anything to help us diagnose programs or problems along the way. Okay. You guys will need to make sure you are set to debug level. So when you look over here in your file that we copy and pasted, you'll see that the logging level is set to debug. All right. That's the reason I want you to copy and paste. It's already set up. Okay. Then there's other levels as they progress up. So you have the info level, you have the warning level, the error, and the critical. Again, this table is essentially upside down. Remember, logging debug is the lowest level, which means it will contain all of the ones above it, including critical, warning, info, errors, etc. So if we set it to debug, you get everything above it, depending on which section you set it as. All right. If you want critical and error warnings, critical, error, warning, and info, you can use any of these throughout your project, and they're meant to be used at certain levels. So debug should be used for any generic information that would help you troubleshoot. Most people will run your program at a warning level or an error level, all right? We're running it at debug, which means you should not flood that log file with a bunch of erroneous data. You should only flood it with typical warning stuff unless they set it to a debug level. Does that all make sense? If you're not troubleshooting the app, you don't want to flood the log file with a bunch of erroneous information. You only want to basically put the stuff that is warning, error, critical. Now, there's a big difference between warning, error, and critical. Warning is going to indicate a potential problem that does not prevent the program from working, but might do so in the future. Okay. So if you guys are doing something in your project and go, that doesn't look right, it doesn't cause a problem now, but it might in the future, that should be a warning level log. Okay. Error level is used to record any errors that cause the program to fail to do something, but it does not crash the program. Make sense? So they type something in like a username, it fails to save the file because the file name is incorrect. That would be an error level log. Any questions on that? The last one is critical. and this is the highest level, and it's used to indicate a fatal error that has caused or is about to cause the program to entirely crash. All right. Now, in your projects, should you ever have a critical?
Probably not.
The hope is no, right? I mean, your project should never crash. Hopefully, right? So where would you use a critical? A critical is typically when you guys are going to import third-party files, or in this case, when you guys are using multiple files for your final project, which you probably should be at this point, it's when you import those other files in that you can have that cause for a critical error. Does that make sense? And why would that be? What would be the critical error when importing things from a second file? Right. So commas, but it's really the file doesn't exist, right? You only copied the one file, you forgot the other file, or it's named incorrectly, or something else is going on along the way. So for example, if you guys have something in your final project, like I'm going to call it cars, just for the lack of an excuse here. And we have a dictionary here, and we call it a name, and we call it my car. And we set a year. The data here is irrelevant. I'm just getting some kind of dictionary. All right. So you guys probably have a lot of these, right? So for some of you guys that are doing like the mech and the D&D cars, etc., or you guys that are doing the stories, that kind of stuff, you have a bunch of data that's just static data. And if you have a bunch of it, you probably have 1,000 lines of code, and it's hard to read where you get to the actual program. So what you should do is kind of copy this over. You're going to open up a new file, paste it in, and we're going to save this file as like data.py, right? It's just my data will be stored in this particular file. So let's save this out. I'm just going to save this in the downloads. Okay, so I have data.py. I have my original project, which I can now remove this stuff from. And then I need to import that data in from that other file. So I would say import data. And if I import data, what that means is now I have data.mycar, right? And that is the equivalent of having the dictionary in the other file. Okay. When you play with that data, you always have to prepend it with data.something. No different than if you guys import prettyprint, right? In order to use the pprint function, you have to say prettyprint.prettyprint, right? Same concept. All that does is go to the prettyprint file. It wants to use the prettyprint function, so I have to address it as this. The other way of importing would be from data import star. And what that does is essentially copy and paste everything that was in our data file back into this file. So now I can just address it as my car anytime I want to use it in this main file. Okay. There's pros and cons to doing it either way. If you're doing a bunch of data like this is probably fine. If you are moving all your functions from the main file off to a second file called my functions, then you may want to do it the other way where you have to do a dot something. Now, the problem with that is you already coded it one way. You're going to have to go back and replace all the names of those functions to match that style, right? If you don't want to do that, you simply do it this way. From whatever import star, it literally just copies it right back into the original file so you keep it clean. So in your guys' final projects, you should have your main program, you should have your functions in a file, and you may potentially have your data in a file. All right. You could put the data in the functions file. That's fine. I recommend putting it out in 3 so that you know if a function's broke, you go to that functions file. You know, if your data is broke, you go to the data file and you modify it so you don't have to read through a bunch of lines of code to find it. On the function side, you may have player functions in one file. You may have computer functions in another file. However you want to break it up, it doesn't matter. The more you break it up, the easier it is to go find it in that location, as opposed to searching through thousands of lines of code. Again, everybody's played a game or installed an application. How many files do those programs usually have? Yeah, hundreds, thousands, depending on how it's broke up. So I don't expect you to do that in your project. You should only have a handful of files. Or if you guys are writing with a story.txt or you're using text files, if you guys are storing your information using the P format thing that we learned, you should have that as your secondary file as well. It's another reason to move your data off to a second file is now you can use that P format stuff that we learned to add information that the user wants to store, right? So you have a predefined set of mechs, for example, right? If you want the user to be able to define their own mech, you have them do that, and then you tell it to say to that same data.py file, it just appends it at the bottom. The next time you go to import it, it goes ahead and imports all the settings and it's saved from their user point. Or maybe you have your data.py and you have a custom file, and the custom file is all the data that the user entered in. That way you can keep those two separate. Here's the one that comes from the original. Here's all the custom ones that they entered in. That's probably the better way to do it, because then you can just say import everything in this file and be able to pull it in. Anybody got any questions on that? Okay, so go ahead.
Do we have to split it up in different files?
Yes.
Okay.
So the reason for that is if you don't, you never have a critical issue on your program, right?
Yeah.
So we need to, in your final project, you're required to have a debug statement and you're required to have one critical statement. So you'll never get that critical statement if you don't break it to a second file, unless you're using third-party modules, in which case you could use this fashion as well. But you should be using big third-party modules that we did not learn in this class, right? That comes with the OOP part. We'll talk about it. So to solve that, all you have to do is do a try here. From data import star. If that all goes well, then we could do a logging.debug statement that sets data imported successfully. And that just starts out in our log file for us to be able to see. If that doesn't work, we can do an except here. And now we can do a logging.critical. And we could say something like data.py file not found. Okay. We should then, spell correctly here. You should print that out to the end user so that they know something went wrong. So you can just copy and paste this here to a print statement. And then at this point, we want to immediately end the program. If your file can't be found, we don't want to continue in your program, because what's going to happen? Yeah, your program's immediately going to crash to a red screen, which is a loss of 25 points on your final project, right? So we don't want that. So we want to end the program cleanly. So we put sys.exit, which means up here at the top, we need to import sys.
No, I tried set. I basically just put the one. Try set statement. Broke out of it.
Yep.
So I just need to clean it up.
Yep. So you basically just add in these pieces. Now, in the rest of your project, you can use logging.debug or any of the other levels throughout, and you should be using them as appropriate, right? So in the beginning, you could even say logging.debug. And in here, you could say starting the program, right? And then somewhere else in your functions, you should have a logging.debug, whatever, so that, for example, if I take input, well, then I probably want to gather, for example, say name equals input, whatever, right? In my logging.debug, we would say something like user typed in that, we throw in name. And the idea behind that is we now have it in our log. So we know what the user typed in, so that when we try to recreate whatever they did wrong, we can see why it's breaking our program. Okay. So think of these logging.debugs just like print statements. The only difference is it's saving it out to a third-party file, in this case called myprogram.log. You can change that name if you want to, I don't care. And that way I can go look at your log file and make sure things are showing up correctly. So if I run this project here, which I got to save, so we could call this my final, see here, downloads. And at this point, it's just blanking for my input because I forgot to put some kind of prompt. So I just put Jason and notice nothing happens, right? If I go to that downloads folder, you'll notice I have this text file. And inside that text file, it creates this logging as it goes through. So we can see that the import file worked correctly. See if I can zoom that up here. We can see my first one was imported successfully. We can see where it started the program. And then we had my logging statement that told me whatever the user typed in, right? It's really handy so that you can go back and troubleshoot. Right now, for you guys, you're always doing print statements. Then you got to go remove the print statement because you don't want it in the final version of your project, right? You just wanted to see what the variable was. Now, instead of doing that, just use a logging.debug, spit it out in this log file so you can go figure out what the user's typing in. Or in this case, what you're using to test with. Does that all kind of make sense? Anybody got any questions on there? Now, here's the problem with the code that we just wrote. Right? So I'm importing data. It comes over. If I come back over here and edit the data file, and for example, I leave off this bracket, right? Well, we know the program would crash because it has no idea what this is anymore. It's a Python error. So when I come over here and I actually run my program, I'm going to get an error that the data file is not found. Well, the data file's there. It's just that I have an error in the data file. So what you guys will want to do when you're troubleshooting that kind of thing is come back over here, highlight this entire section, format, comment out region, and then from there, just copy that first line back in and go ahead and run. And that will give you the error so that you know I need to go to the data file, look at this particular line and see it was never closed. Okay. Once you get it to run and there's no red output, then make sure you come back over here, delete this line, highlight these, format, uncomment region, and it goes back to that version. Most people will freak out because they're like, well, the file's there, it's just not running. Well, that's because of the error that you told it here, right? If I change this and said, or you made an error in the data.py file. Okay, well, now it's going to give you better information to know either the file's not found or I made some kind of error in the other file. All right. That's the importance of having really good logging information out to the user. Now, notice I added this to the logging section. I forgot to add it to the print. So the end user is just going to say the file's not found. Make sure that you copy the information between the two of these. All right. That's the biggest part that trips people up is they start making a bunch of changes in the other file. They made a typo somewhere. It happens. You've watched me do it a million times in this class. All you have to do is copy this out, this one line, and then try to do an import and watch it fail so that you can go figure out where you need to fix the code. Anybody got any questions on the logging? Again, you must have a logging.critical, you must have a logging.debug, and they must be used correctly, right? So logging.debug, pretty much using that correctly just means that you're using it for informational purposes. Somebody's trying to use it to debug your program. Most of the other ones should fall under logging.info, maybe a logging.warning. You would have a logging.critical at some point when the program could potentially crash. Now, this could also be at a point in your program when you're trying to save a file out. And if it doesn't save out correctly, the program crashes. That's a logging.critical. However, you should code it in a way that the program wouldn't crash. It just wouldn't save successfully. Does that make sense? You should rewrite that as a logging.error, show that there's an error for whatever you're trying to do to save that file, but it should just allow you to go back to the main menu of your program and continue on from there. Again, to get started, you come down here to logging.file, copy paste, fix this because this wraps to the second line. So you need to fix that. From there, you're going to do some kind of code that looks like from data import star, etc. If you have other imports in here that are third-party imports, not sys and logging, those always need to be at the top. Note that above this, you would have your 3 initial comments, right? You're going to have a block comment statement. And this should be explaining what your project is, etc., everything in between. You should start with immediately logging and sys. Then you should have your series of try and accept statements for all your third-party modules. So say I installed Paperclip in my project, right? Well, then I need to do a try from, and then I would do my import Paperclip, just like we learned in the class. Logging, debug, Paperclip, imported successfully. Then I would have an accept statement. And in this case, I would have a logging.critical that would say Paperclip not installed. Please run pip install, whoops. Pip install Paperclip. And then you would copy and paste that into a print statement so the end user knows that, hey, they forgot they have to pip install the Paperclip module in order to run your program. All right. You must put this pip install Paperclip. If it's a third-party module, you must say pip install whatever that module is so the user knows that they need to install it. All right. Come down here. The rest of this all looks good. And you're good to go. If you have any other third-party modules, go ahead and do try and accepts. If there are things that are built into Python, like the math module, you could go ahead and just import math at this point and continue on. Okay. This is why you always want to put your imports at the top. If you did this in the middle of your project, you would get all the way down to your project at the point it would do that import. That module's not installed, the program crashes, right? You should catch that immediately before it ever runs the first line of code of print hello. Before it ever gets here, we should check every single module to make sure it's valid. Put it into a logging statement so that we know what's going on. Anybody have any questions about that for the final? Again, biggest mistake is you don't copy and paste this, right? Copy and paste it. You need to make sure you have a logging.critical and a logging.debug in your program. You should have multiple of those. It's a requirement that you have one of each, but you should have multiple throughout your project. So probably not multiple logging.criticals, because probably won't, unless you had 2 modules like this one here. When we actually imported this one in, right? I have 2 logging.criticals here because I have Paperclip and I have the data file. But I should have logging.debugs throughout my project, or warnings or errors or even info. You can use whatever you want. What those, all you do is you just set the level by saying logging.debug or logging.critical, logging.warning, etc. Up here is where you tell your program which level it's going to be running at. So at this should always be set to debug. Now the difference is if I forget this file name and I use the other one, now when I run this program, too many of those. It comes back, but I start seeing the error logs directly on the screen. You should not be formatting those in a way that you are printing information. So again, you're not removing your print statements that you already have in your project. You should keep those, right? You should only be adding the logging dot whatevers so that it goes to the log file. So a lot of times students go, oh, I'm supposed to replace any print statements with logging dot whatever. No, you're only replacing the ones that you're using for debug purposes, and you're leaving your print statements in so that they should see everything in blue. In other words, in your project, I should not see these red statements being printed out. All make sense? Okay, So as that pertains to the final, let's go back to our homework here, logging modules. Here's the rubric on your final project. You'll notice it's very similar to the first one. It just has some additions. So 20 points now as opposed to 25. Does the program execute with no errors? You should have another 20 points of the use of functions, lists, dictionaries, etc. Same thing that you had on the first one, right? The wording's the exact same. 20 points for the project being well documented, meaning that you have your initial comments, the block comments, and some comments throughout the entire program. You have 20 points for the logging module. How you get those points, you copy and paste that in. You have on your try and accepts in the very beginning of a debug and critical, boom, you have 20 points. So not 10 points, right? 10 points is the setup, 10 points for the logging, critical, and logging.debug. Make sense? 10 points for setup, 5 for each of the other ones. So if you forget logging.debugs, you miss 5 points. If you forget logging.criticals, you miss 5 points. If you didn't do the setup for logging correctly, you miss 10 points. Make sense? Otherwise, you simply copy and paste a few things in and you immediately get a 20% on your final project.
Yeah.
Watch this video that we're recording now. That's all you got to do. In the midterm, when I start grading your guys' homework, I will say, please watch the logging video to make sure you get the right setup. I put that at the end of every single one of those for a reason. It's 20 points, easy points. All right. The last 20 points is going to be your object-oriented programming. We'll cover that once we get to that stage. And there's actually a video on this whole overview of the final project. But the key I wanted you guys to know here is today is a pretty good important video because it's worth 20 points of your final project. You just copy and paste things in. And then throughout your project, you need to have some statements along the way. If you guys had comments already, great. Copy and paste these in. Reword your comment to make explanation. I'm running this function for this purpose or something that would give you some helpful information, right? The goal is that if somebody goes and uses your project and you say, set the logging level to debug, give me the logging levels or the log file, you should be able to troubleshoot your own project based on that log file. If you don't have enough information, go back to your project and add in the places that you need more information. Once you start coding this way, you will ask why you ever did the print statement. Well, it's because you didn't know any better, but you will at least have a ton of information as to what's going on in your project. You no longer have to do print blah so I can see what it is at that point in time. I can simply do it in my logging file and I can see what's going on at that point. And if you're super fancy, you can actually find a way to watch that log file in real time so you can watch it on a separate screen. I don't teach that, but you can't do that. It's a pain in Windows. Linux is easy. All right. Anybody got any questions on logging, debugging? The rest of this section on debugging is going to talk about using the Mu debugger. Remember, we're not using Mu, we're using idle. So you can pretty much ignore that. If you go back to the original version of this, note that we're on the 2E version. If you go back to the original one, it'll tell you how to do it in idle. To be honest, I don't teach this part of it, even though it's somewhat helpful. You would learn this in a better better IDE environment later down the road. So for example, in Python 2 or the advanced Python course, you guys will use PyCharm, which has a built-in debugger to help you figure out what's going on along the way. But in this class, you could use their debug section, in which case what it does is the same concept here. You set up breakpoints and then you can run your code. And once it hits a breakpoint, it pauses so that you can pause your program and it doesn't just spit it all out at once. It's a way for you to kind of stair step through your code. It's not as helpful as it sounds in these kind of projects. It's better that you use your loggings and kind of go from there. All right. Anybody have any questions over this week's information? All right, I'll stop the video.